What did the acorn say when he grew up? Geometry. Geometry. Boys and girls, welcome to our very first video lesson in geometry, section 1-1, undefined figures. You should have your note packet open. It should be open to page 1. You should be taking notes as you're watching this video. And if you need to, stop the tape at any time so that you can write stuff down without falling behind. All right, let's go. Okay, we're going to start with our first term. Our first term is a point. A point is a location in space. It has no dimension. It has no size. There's no length, no width, no height, no depth, no nothing. A point is just a spot. So we name, points are zero dimensional, and we name them with a capital letter. So this guy right here, this would be point A, and this guy right here, that's point B. We name points with one capital letter. Okay, our second figure is a line. A line is a one-dimensional figure that goes on forever on both sides. It's an infinite number of points. It goes on forever in both sides. Okay, all lines are straight. Lines are determined by 2 points. You've heard that. 2 points determine a line, and we always name a line with just 2 points. We name a line with just 2 points. So if you look at these 3 lines, there are 3 ways to name lines. We can name a line with a small letter, like this here would be line N, so I would write that as line N. We won't do that too often in class. You can name a line with a number. We'll do that sometimes. So this will be called line 1. Okay, and most often we're going to name a line with, yes, that's 2 points. We're going to name a line with 2 points. So I look at my line. I'm going to choose any two of these 3 points and name my line with any 2 of those 3 points. So this could be line XY. I draw a little line symbol. I could name this line XZ. As long as there's 2 points on that line, I can name it. Okay, I can name this line YZ. Notice I'm drawing a line symbol above each time. I can reverse these. So I can call this line YX. I could call it line ZX. Or I could call it line ZY. What I don't call this is line XYZ. We don't name lines with 3 points. That is wrong. Our next figure is a plane. A plane is a flat surface with no boundary, so it's an infinite flat surface, goes on forever on all sides. It is 2-dimensional. It is determined by 3 non-collinear points. That means that points that are not in a straight line. And we always name a plane with this is wrong. This should say we name a plane with 3 points. We always name a plane with 3 points because that's how we determine a plane. So I could name this plane right here as plane M with a small letter. We won't do that too often in class. Or I can name this plane with any 3 points that are on it. In this case, there are 3 points that I can see, A, B, and C. And I'm going to draw my little plane symbol up above those points. So this is plane A, B, C. And we will do that once in a while in class. Okay, a space, our next shape, is a 3-dimensional figure. Okay, it's determined by 4 non-coplanar points, and we name a space with 4 points. Notice that we've gone up 1 time in both dimensions, how we name them, and what they're determined by. Our next figure is space. Space is a 3-dimensional figure, so it has 3 dimensions, a length, a width, and a height. It goes in and out, back and forth, and up and down. It's determined by 4 non-coplanar points, so that's 4 points that are not on the same plane. And we always name a space with 4 points. We won't do this hardly ever in class, but just want you to know that space is the next progression beyond the plane. We cannot draw a space because space does not fit on a piece of paper. A piece of paper is a plane, and space requires more than a plane to be able to draw it. Space is the world we live in. Okay, our next terms are line, a line segment. It's a piece of a line. In other words, it's the part of a line where it ends on both sides. So it ends here at point N and it ends here at point M. We call M and N the endpoints. So I'll write that down right here, endpoints. Okay, we always name a segment with its two endpoints. So this segment, the first one, would be segment MN. And I draw the segment symbol right above it. I could also call it segment NM because N and M, again, are both my endpoints of my line segment. My second line segment right here is segment AC because A and C are my endpoints. So I'm going to write this as segment AC, or I could call it segment CA, but I could not call it segment AB. Segment AB would just be this segment right here. I could not call it BC. BC would be just this segment right here, and I certainly would not call it segment ABC. We name a segment with just 2 points, not 3. A ray is like half of a line. It is finite on one end. It means it has an endpoint right here at D, and it goes on forever on the other side. So it goes on forever. It's infinite on the other side. So we name a ray with its endpoint, which in this case is D, and any other point on the ray, and we draw a ray symbol up above those points. So this ray right here is ray XZ or ray XY, but my first point must be the end point, so point X. So I can call this either XY, I could call it XZ. Either of those two names would be correct. I cannot call this point YZ because YZ would be just that little ray, or that's a little bit less of a ray, starting right there at Y. I also could not call this ray either YZ or ZY or ZX or anything else because my first point, if I made this YX for example, that would be this ray starting at Y and going this way through X. I must name a ray with its endpoint and then one other point. Alrighty, the next figure is an angle. An angle is two rays with a common endpoint. We call that endpoint the vertex. Okay, the symbol for an angle is a little angle symbol that looks like that. Okay, so my vertices for each of these angles is right here. The endpoint of my two rays right here and right here. When I name rays or angles, I can name them a number of different things. This we're going to call angle 2. Okay, I can name it with a number. I can name this angle angle G with its vertex. Or most often, I'm going to name an angle with 3 points, the middle point being the vertex. So I can name this angle ABC because I have my middle point is my vertex. Or I can name it angle CBA because, again, my middle point is the vertex at B. I could not, this would not be correct to call this angle CAB or BAC because A is not the vertex of my angle. Okay, how many angles do you see in this picture? How many do you see? Not 2, but yes, we see 3 angles. We see this angle right here, that's angle 3. We see this angle right here, that's angle 4. We also see the whole angle put together. So that big angle would be my third angle. So let's just look at the little angle first, this red angle right here. I could call this angle 3. I could call this angle WXZ. I could call this angle ZXW. Notice that my middle point is my vertex, which is X. I could also call this angle X. That would not be wrong, but there are actually 3 angle X's that we see there. So this is not a good answer. And we typically are going to name angles with 3 points. Okay? Why don't you guys right now stop the tape and name angle 4. So name this angle right here at angle 4. Name it all the different ways that you can. There should be 3 different ways. Go. Okay, very good. This angle right here is angle 4. It also could be called angle ZXY. zxy. Notice that my middle point again is x. I could also call it yxz, so yxz, my middle point being my vertex x. Of course, I could call it angle x. This is an angle x, but there are two other angle x's there. Okay, and of course, if I wanted to name this big angle, the big angle right here would be angle WXY. Couple more words you need to know. Collinear means on the same line. On the same line. Non-collinear means not on the same line. Hey, hey, hey. Coplanar means on the same plane. And non-coplanar, of course, means not on the same plane. Okay, so looking at this picture right here, use the figure to name each of the following. A line containing point N. Well, point N is right here. This is the line that contains point N. Okay, I can name this line C. So I could name it line C, like line C. I can take any of these 2 points, take any two of these 3 points. So I could call this line MN with my line symbol. MO, or is that a Q? I'll call it an O. MO. I could call it NO, or the reverse of any of those, but I take any of those 2 points and name my line with any 2 of those 3 points. I'm looking for a plane containing point P. Well, point P, of course, is right here, which is on the plane. So I can call this plane A. So plane A. Or, of course, I can name this plane with any 3 points that aren't on the same line. So I would need to use P and any of those other 2 points. Let's choose M and N. So this is plane PMN. Or I could do plane PON, just any of those 3 non-collinear points. Okay, you guys try these right now. Stop the tape and answer these 4 questions right here using this figure that we see to the right. Okay, decide how many planes appear in the figure. Name 3 points that are collinear. Name the intersection of plane XYZ and plane M. And at what point do lines PR and TZ intersect? Explain. Stop the tape and we'll be right back. Okay, welcome back. Here are your answers. How many planes appear in this figure? It looks like there are 4. You got plane M, this bottom plane right here, so this flat surface right here. You have the plane right here that is through Y, T, and X, so this plane that goes through right here. You have the plane that is through Y, T, and Z. This plane right here. You have the plane that's in the front right here, W, X, and Z. So this plane right here. Okay, so there are my 4 planes. Name 3 points that are collinear. The only 3 that are labeled would be Y, Q, and Z. Y, Q, and Z. Name the intersection of plane XYZ and plane M. Well, plane XYZ, it was this one in front right here. And plane M was this bottom plane. They intersect in the line XZ right here. Okay? So all 2 intersecting planes, they intersect in a line. And at what point do PR and TZ intersect? Well, PR is right here. And TZ is right here. They do not intersect because TZ does not pass through P. All right, they don't intersect. Okay, the last exercise we're going to do here is we're going to draw a figure based upon the descriptions. So we're going to start by drawing plane R. So here's my plane R, just this big piece of paper. We'll call this plane R. Okay, it contains 2 lines, AB. And ED, and E and D can be wherever they want on that line, and they intersect at point P. We need to add a point C on plane R, so that is not collinear with either AB or ED, so just anywhere else. I'm going to put a point C that's not on neither of those two lines. All right, that's it, folks. Have a great day, and we'll see ya mañana.